exciting to work on. And here it is in perspective, kind of not rendered, but in a realistic view. And I just set that up, as well as plans and elevations, sections, just very simply drawn from the overall 3D article. So how this was set up, I can look at in the article designer by going to modify article. And it's kind of easier to see if I minimize this stuff here. Just walk through it from the top. So here's your overall article, and within this first area you have divisions, and the divisions are horizontal in this case, and they're defined vertically in space by this linear division here. So this first number is the height of the toe kick. If we wanted to make it, you know, a bit taller, we could do that, and everything adjusts parametrically as far as the zones with that. Same with the top here. Just make that a bit taller there, and that's with this one in the middle fills the space that's not defined by these numbers here and the height that I have chosen here. So just kind of go back to the head. We'll dive into this a little bit deeper. So once that's divided, I have another zone here on top, and within that zone I have a couple more dividers, one over on the right side for kind of a setback for this top piece, which was 3/8 of an inch, and here I've set it back 3/4 of an inch, and this lower piece will be set back 3/8 of an inch, so there ends up with a 3/8 kind of reveal on the top here. But again, left to right, this linear division is defined here. With the sort of complicated glass area here, I did do some oversizing on different panels to fill that space accordingly. But left to right, we're defined here with another division, and we can dig into that further, and we see over on the right we have this zone. There's really nothing in there. It's just space moving it over 3/4 of an inch. And then here we have, I guess, our middle zone in this case. And within our middle zone, we have top shelf, which has kind of a special construction principle adjusted for the mitering situations, and I won't delve into that one. That wasn't very much customization on that. Left and right sides, these are just typical library sides. Here you have options on how you're going to treat the edges and the connections. In this case, for the next connection, that refers to the back. Front would be previous, next is the back. And as you're going around, you know, counterclockwise, it would be previous would be the right side of the back, next would be the left, previous would be the back of this side, and next would be the front. So got to get used to the terminology a little bit, but there you have some trims and how that's mitered. Back, this is a back panel, which has certain properties, allowing you to oversize it, which I've done to kind of drop down, which is sort of what it looked like was happening in the 2D drawings. It was hard to tell for certain, but I've oversized it in a couple of ways here, undersized it in this case, and then oversized it to get it to come into the area that I needed it to. The back here, just mitered left, right, and top. Then this is divided again with this here, partition in this case, which has its own construction principle and connectors. We got a zone on the right, which has our keyboard pullout. And the keyboard pullout is actually a shelf, virtual shelf here defines the space in this case. Then we have our upper zone, which shouldn't have anything in there. And then our lower zone, which has our top shelf, which again is not necessarily a top shelf, it just has certain properties. And I came up with a construction principle that would define that shelf and kind of make it the right size for this pullout. And then the drop edge here is defined as a back. And then there's some movement here with the bottom being undersized, and that's basically the whole upper zone. So now I could, over here, look at the glass, and as far as the glass goes, have this piece here, which has some oversizing, undersizing to just fill the space here. So this is a little bit more hard-coated, and you get some parametric properties for it, but not necessarily 100%. You might need to make a couple of small adjustments to it. And then again, here is the back, which is glass. And that's all that's in the upper zone. This piece here will be part of the middle zone, this glass piece, as well as that side. So you will come into the middle zone vertically and look at our first division here, which is a virtual division, defined by this. And like I said, this zone over here on the right side is just 3/8 of an inch to kind of get that reveal working like it needs to be. So I could change this parametrically on the left side, for example. Just bring that over, and now we got a real narrow shelf here, and all the glass and everything is still lining up like you'd expect it to. Move that back over and look a little bit further.
So basically what you're saying is you can take an existing, these guys never do the same thing twice, but you're taking you just took the existing fixture that you built, and by changing a couple of parameters in there, actually readjusted the fixture to a new fixture.
Yeah, that's correct, Roger. And also what I didn't mention is where you have these kind of hard numbers, this could be a variable also, so that when you change this variable, which I have over here, this $sign, I'd have to get into the variable table to show you closer about that, but you could have a variable here so that if this was subject to change on a job-by-job basis, you could define that in your variable list and then not even have to come in here and mess with the numbers, which is nice in some cases as well. So I'll just continue going through here. This piece over here is just space. This here has got a couple of different divisions going on. And here I have it divided in the back because there was a bit of a reveal or a zone in the back that needed some extra space, and I could bring it, forward by 10 inches if I wanted to, and everything adjusts parametrically that way. And just move it back. And here we have top shelf, right. A bottom shelf kind of spanning 2 article zones. That's what it looked like. Might be built like from the drawings that I got. And here's a division. These are 2 article zones on the left and right side of that. And again, parametric here. So within this side, I have a virtual divider, and then this is an article zone. So in the article zone, I have actually an article designed, which is called the AZGR.
Can you please explain the difference between a virtual divider and a real divider?
Sure. A virtual divider would just kind of define spaces within an article, and it's a zone separator, so that you could have a divider be a partition, for example, and it is a partition, and I could come and make it an actual partition, and there's an actual partition with the construction principle and machining associated with it. But in this case, it just made more sense to do it as a virtual divider and then have that side actually in the article zone.
Right.
So I would have
I can come up with any cube or any even with radiuses in the front. In other words, you just started out by saying this is the height, width, and depth of this article, but you could start with radiused articles and stuff like that and build it up from there using the virtual space dividers and stuff like that. Also, correct?
Yeah, absolutely.
I'm just trying to give them a broader picture beyond this particular fixture.
Yes, you can define that. We're in a plan view right now, and I can do outline geometry to define a different sort of outline in the plan view. As you see here, the corner is sort of clipped on this plan view cabinet here, and that's the zone I'm working on. You also have an option to look at it in the elevation view with the corner clipped, so that like perhaps you could have an article that fits under a stairway and the top is sloped to tuck right up under there. So there's lots of different ways to lay out the outside of it and then fill in the spaces.
Does this article have doors?
No, there's no doors on this.
Okay.
I don't believe there's just drawers.
Okay.
But yeah, we can look at an article with doors. And that's...
No, I just they really wanted to see this. Disappointed, and I'm so happy that you're able to take the time to show them this. And I will finish up copying this, put it out there in YouTube, and enable them to see this recording of how you were able to achieve that. This is a tough question because giving them the real idea of how long it would actually take them. But assuming that these guys were pros at figuring out how to divide the space up using these virtual dividers and laying that out, they're going to end up doing it every single day. Or they'll build parametric units, which probably require very little modification. But just from scratch, assuming that you had the proper parts, drawers, doors, sliding shelves, hardware, and all that, how long do you think an experienced user would take to achieve this fixture?
This is fairly complicated. Lots of ins and outs, but less than a day, I would say, is reasonable. One of the more complicated areas maybe I'd have to actually go out of the article and just show you one of the more complicated type of areas in here, and I have to go and select one of the articles that's within the article zone. And your top shelf looks kind of blocky, but there's actually a lot of intelligence here. And here I'm in the construction principles, where I have options to, protrude or inset with numbers or variables there, and connector situations. And then of course I can go into look at my part definition, and here's my part definition, where I have part type, and it's a multi-part in this case, and the edge profiles and connections and machining that could occur on that. But we'll dig a little bit deeper into the multi-part, where it has kind of individual items applied. And then here you're looking at your multi-part, which has construction points in here for layout, and then you actually apply your part definition to the construction points. In this case, it's just a drop edge, I believe. Yep. So that has its own limitless amount of definitions, and just laying out how this all comes together, and with the offsets and z-values, and then kind of doing the stretchable purchase part from scratch, which is this profile here, which is a metal extrusion that's in the cabinet. That's all part of this multi-part. And once that's done, then of course you can just apply it right here very easily and move on to the next item. In my case, I had to spend a bit of time, you know, working with that to get it adjusted exactly like I wanted it to. So that's what took the bulk of the time in kind of my setup for this. You know,
so if they had that already established, it wouldn't be quite as dramatic. But even at this point, you know, now that you've spent, let's just say you've spent 6 to 8 hours on this project, at this point you have a cut list, you have a parts list, you have a purchase list, and you have G code. Is that correct? I mean, I know you haven't generated, but you've got the data to push the buttons to send it off to a point-to-point or a router or a saw combination with having done this. So, I mean, one of the things that we talked about last Friday at on site with Global Fixtures was a conversation between Tim and Jeff. And they basically, currently, the way they do it is they do 2D drawings. Tim, who basically, I believe he works for Brian Murphy's unit or team, and then that goes down over to Jeff, and then Jeff has to pull off the parts, and then he puts them into Ned Brown's CAD code, and Ned ends up doing some calculations to reduce the part to the cut size. And that's what they currently do, and so we're looking at somewhat of a hybrid position to where both Jeff's efforts and Tim's efforts yield the same results, with Jeff having oversight on all of the input to the factory. I think that's where we're at with this particular company. But anyway, go ahead. You were showing them.
You mentioned the reports, and I just wanted to kind of touch on that. And here we have a little bit hard to see here. I'll zoom in a bit and make that bigger. Okay. Well, your perspective view, elevations, and these are all sort of automatically generated as part of this report. And then if we get into here, there's a problem with my templates where I have something coming in out of scale here, and I got to adjust that. But here we basically see all of our parts dimensions and then a call out on the perspective of where it exists in the article, as well as a barcode which you could scan and run this part at your machine. So a lot of information there, and it's for every single part. We could go through all the way to the end where we have purchase parts, drawer slides, and even down to shelf clips and dowels. And there's a stretchable purchase part, which in this case doesn't have very much detail, but you can of course call that a style mark, you know, whatever you want. So that's kind of some of the information that exists there already. And if I wanted to look at something with machining here, I could just select it, look at it in my list, select it, and here's in the list. And if I wanted to look and isolate it, I'll just isolate that element. And here's that shelf, and look at 3D workings. So 3D workings kind of shows a bit more detail on the routing. It's not exactly maybe what you'd expect, but it gives you a good idea of what is going on with the machining for this. And just show all elements again.
Yeah, it definitely lets you drill down to individual parts. Can you show the Visio Manager and show how you can go from some details to major details, how
Sure. Yeah, I usually, because I have a fairly speedy computer, I'm able to work in the full render mode most of the time, and I don't mind seeing extra edges, but you can bring it down to just engineering details in this case, and then define what you want to see in the engineering details, which in this case is mostly the same as the render. But if I come down into planning, look at that.
This is kind of what I was thinking that this is kind of what I was thinking Tim might be using for space planning. They do space planning before they dial into the actual fixtures, so he could get at this level for speed, and then dial it up for the one-off generation.
Right, and if I come all the way into Modus 1, that really is just 2D space planning mode. And drop down into that, see what it looks like. I never actually checked that for this article. It'd be interesting. It seems to be running a little bit slower just due to this meeting.
Yeah, those go-to meetings always.
So here is just the overall outline of this article with some details about it, height, width, depth. This is actually late Tuesday, so I named it that. Of course, you can name it anything you want, but this is the most basic visual level where you could, for example, have cabinets all just laid out 24-inch wide drawer cabinet next to a 36-inch wide sink cabinet, and just lay out your squares that way, and then hand it off to the maybe engineering guy. You would pump up the details to look at much more of what's coming in, and can make adjustments or customize on a case-by-case basis.
Okay, well let's go ahead and stop, and I'm going to stop the recording right now. Hold on.